vectors. We will look at what they are, what do they look like, their properties, resultant vectors, many to one, in other words, changing many vectors into one vector, rewriting vectors as their resultants, one to many, and then we will go through some examples. So, what is the difference between speed and velocity? Velocity is speed combined with direction. That is the important bit. It is speed with direction. What are vectors? A scalar quantity is simply anything in life that can be described by just a number. E.g., the temperature, my age. However, a vector is a quantity that needs a direction as well for it to make any sense. Vectors have both magnitude, which is their size, and direction. Examples are velocity equals speed plus the direction. E.g., wind velocity is 20 kilometers east. Displacement equals distance plus direction. E.g., the displacement of Leeds from York is 25 miles west. Vectors are directed quantities. What do they look like? Vectors can be represented as straight lines. The arrow shows the direction in which the vector is traveling or moving. The length of the vector is its size. You can also represent a vector as a column vector. Two numbers, much like a set of coordinates. So this one is 3, 1. 3 spaces in the x direction, 1 space in the y direction. There is the resultant vector. Vectors are pathways. They go from one point to another. This vector goes from A to B. You know that because the arrow is pointing from A to B. The most common notation for a vector is threefold. Capital letters AB, denoting the starting point as A, the finishing point as B, with an arrow above showing the direction. As a bold A, little a, or a little a with a straight line beneath it. So there is vector A and vector B. The resultant is a single vector which is equivalent to a set of vectors, e.g. the result of adding A and B. If we put them together, we can go along A and then along B. The resultant vector is the broken line. That is the same pathway. So C, the broken line, is equal to going along A and then along B. Another example, A minus B. Again, the resultant vector is the broken line. In this case, C is equal to going along A, and then along minus B. Vectors with the same magnitude and direction are equal. These two vectors are equal. They are pointing in the same direction and they have the same length or magnitude. This vector from A to B, if vectors have the same magnitude and opposite directions, then the vector AB, which is equal to little a, then the vector BA is equal to minus little a. If different size vectors have the same direction, they are scalar multiples of each other. E.g., vector m is a multiple of n. There is the vector m, there is the vector n. In this case, m is twice as long as n, so m is equal to 2n. Rewriting resultants. Resultant vectors can be broken down into their component vectors. E.g., little a is equal to xy. That is the vector x in the x direction and the vector y in the y direction. Vectors can be rewritten in terms of other vectors. So this vector little a the vector little b, so c is equal to a plus b. It is the same pathway. Rewrite the following vectors in terms of a, b, and c. Here we have a hexagon. 3 of the sides are represented as vectors. AB is the little vector a, BC is the little vector b, CD is the little vector c. So to get from A to B, we go along little vector A. So BA, we're going in the opposite direction. So BA is equal to minus little a. CB, we are also going in the opposite direction. So CB is equal to minus little b. DC, again, we are going in the opposite direction. So DC is equal to minus c. AC, to get from A to C, we have to go along A and then along B. So AC is A plus B. And AD, to get from A to D, we have to go along A, then along B, then along C. So AD is equal to A plus B plus C. Rewrite the following vectors in terms of A, B, and C. Stop the video and work the answers out for yourself. Here are the answers.